In these two examples, we're going to work with a rule called the product and quotient to an exponent property. If I have a product raised to a power, the way I simplify is I raise each part of the product to that power. So a times b to the n equals a to the n times b to the n. Same thing for a quotient. A over b to the n is a to the n over b to the n. So let's see how that works with some examples. Here, part A, I have 5 times x squared. So if I apply the product property here, it's going to be 5 squared times x squared. 5 squared is 25, x squared, and that is completely simplified. Part B gets quite a bit more complicated. I have negative 8 times a times b to the 5 halves. All of that is going to be squared. So if I apply the product property, I'm going to take negative 8, square that, a, square that, b to the 5 halves, and we put parentheses. That wasn't a very good parenthesis. Let me see if I can redo that. There, that's better. And square that. So negative 8 squared, negative 8 times negative 8 is a positive 64. A squared is just a squared. And b to the 5 halves squared, well, 5 halves times 2 is just 5. So that's going to be b to the 5th. And that is our final answer. Part C, we have a product 5n to the 4th times, then this product, negative 3n to the 3rd raised to the negative 2nd. So we're going to be applying a lot of different properties here. So let's start with the 5n to the 4th, leave that by itself. We have a negative 2 exponent. Let's make that a positive exponent by moving negative 3n cubed all down to the denominator, and that is squared. So I'm going to keep the 5n to the 4th. So I'm kind of multiplying straight across here. Negative 3 squared, I'm going to have to write as negative 3 squared. N cubed squared becomes n to the 6th. So I simplify that to 5 n to the 4th divided by negative 3 times negative 3 is 9 n to the 6th. Now there's a property that I'm going to use here to simplify. You'll learn more about it in the next set of examples. But if I have n to the 4th on top, that's n times n times n times n. I have n to the 6th on the bottom, n times n times n times n times n times n, 6 times. If I remove the common factors here, the n's are removed from the numerator, and I end up with n squared in the denominator. And that is my final answer. You could make it a little bit nicer by centering the 5 over the 9n squared, but that is the final result. Now let's take a look at the quotient to an exponent property. Some examples here. I have 5/7 squared. If I apply the property, that's going to be 5 squared over 7 squared. 5 times 5 is 25. 7 times 7 is 49. And that is my final result. Here I have x to the 5th over y to the negative 3, all of that raised to the 4th power. I'm going to go ahead and apply the quotient to an exponent first. So that's going to give me x to the 5 times 4 is x to the 20. Y to the negative 3 raised to the 4th is y to the negative 12th. Now I want to end up with positive exponents only. So the x to the 20 stays on top. y to the negative 12 comes up as y to the positive 12, and that is my final result.